All right, let's talk about branches now. They split off the parent chain of carbon atoms. The parent chain is just the longest continuous chain of carbons. I might try to trick you at some point with like a bend in the parent chain. I'm not going to do that yet. Okay, but so this is the longest continuous chain of carbon atoms. Okay, the names of branches have the same prefixes as the alkanes I showed you, but they end in YL. All right, so if you see a CH3 hanging off something, that's methyl. If you have a CH2CH3, ethyl. Propyl has 3 C's. I don't think you're going to see a butyl branch. Most of them are methyls with some ethyls thrown in, and you might see 1 or 2 propyl branches. Okay, so here's just a quick example of a branched alkane. Parent chain looks like this, 4 carbons. That makes it butane, and this is a methyl branch. Okay, so this is some kind of methyl butane. Let's talk about how to actually name branches, or sorry, name branched alkanes. So I kind of gave you a preview just a second ago. You identify the parent chain. Okay, but this is new. You number carbon atoms starting from the side closest to the first branch. Then you identify the name of the branch and where it is. Then you write the location, if there's more than one possible location, the branch name and the parent name. Okay, so I've got one here. So step 1 is identifying the parent chain. 1, 2, 3, 4, 5. That's pentane. Okay. Notice you could make this the parent chain. 1, 2, 3, 4, 5. It won't change your answer. If it's horizontal, just do the horizontal chain because it's just easier to wrap your head around. You'll get exactly the same thing if you do it correctly with this as your parent chain. Okay, so 5 carbons is pentane. I'll write that down. That's going to be part of the name of this structure. Now I number the carbon atoms starting from the side closest to the first branch. Well, it's closest to the right. So this is carbon 1, 2, 3, 4, 5. Okay. Identify the name of the branch and the location number. It looks like we have a methyl branch, 1 carbon, on the second carbon atom of the parent chain. Okay, so the name then is the number of location, which is 2. Branch name is methyl. So to name this guy, it would be 2-methylpentane. I have a big gap in there. That's not supposed to be there. I'll write it out. So this structure is 2-methylpentane. Not bad. Notice you could have 3-methylpentane. That would be totally different. Not much different, mind you, but a little bit. I want to go back to the quick just example that we didn't actually totally name, but let's go through the process. This is butane, 4 carbons. It's really similar to the pentane we just discussed. There's a methyl on carbon 2. Okay, so I'll write out methylbutane, but this is a bit different because if I put this methyl branch on carbon 3, what would happen? Think about it for a sec. So let's forget about this branch and then put it here. Then that would change our numbers to 1, 2, 3, 4, and it would be 2-methylbutane, which is what we said this was. In reality, wherever in either of these locations, it's the same structure, just kind of backwards. We don't know which way we're going to be looking at this structure, but a branch here and a branch here is the same thing, 2-methylbutane. Heads up, you can never have a branch on the ends. Can you think of why? If I put a branch here, I've just created a longer parent chain. So a branch at the end would change this butane to pentane. Okay, so in the end, we just found out that a branch here and a branch here results in identical structures. That means we don't have to put the number of the location because there's only one possible place for a methyl branch on butane. This is the answer. It is not 2-methylbutane. And again, it's because that's the only type of methylbutane. It has to be located on number 2. Okay?